Buonasera. I don't usually use paper or print out my talks, but I'm being translated, and the last time that I spoke with a translator, you could see steam and smoke coming out of the translator box, so I want to try and be very kind to Lucia instead. I would like to talk about, well, I'd first like to say thank you for inviting me to your beautiful theater, this beautiful town. I want to think with you about the new bundle of digital technologies that are reshaping our lives and how we make all kinds of transactions. It's reshaping the built environment, and access to digital technology remakes our assumptions about planning and transit and communications. And it's happening in many different ways, and it's being increasingly done by intelligent robots with artificial intelligence, which I'm calling robots during this talk. And robots see differently than we do. They see order and disorder much differently than we do. And some of this is worrying, some of this is fascinating. But we should talk about this because it's important. It's one thing to see these things in words, it's another thing to see them in pictures. And so what I'm going to show you are some pictures about robots and how they think. I want to show you two projects that my studio statement has worked on. The first I'm very familiar with. It is about robots in the stock market. And the second one is very new. We've only just started looking at this in the last week or two, very new. This is work in progress with Aman Tiwari at Carnegie Mellon University, sponsored by Digital Globe. And it's about robots reading satellite information and doing things with it. So this one I'm just learning to figure out how to talk about. But both projects are about the way that we think about disorder and order, and it's changing rapidly and dramatically. And again, because of this arrival of artificial intelligence and machine learning. And in the last years, there's starting to be this mainstream conversation about AI and ML and robots. People are waking up to the fact that when they're interacting with things like Facebook and Instagram, what they're really doing is interacting with an artificial intelligence, basically a very smart robot, is talking to you. And the job of this robot, what it does better than anything else, is to keep you on the platform. And it gets better and better at that all the time. And so we're starting to talk about how these robots contribute to things in the news that are important to us, like the last US presidential election. It seems pretty clear that there were influences in that election by some robots that didn't necessarily have our best interest in mind. And so we're seeing this all play out in very public ways. So I think we should pay attention to this stuff. And so here we go. This is a map of robots in the stock market. And I call it a map very loosely. It's a visual representation. It is a representation right now of a minute of time. Left-hand side is the past, and the right-hand side is the future. And every one of those dots is a trade on the NASDAQ stock market. So the size of the dot is the number of trades. The vertical position is the value of the trade. So the top is very low penny stocks, and the bottom are very expensive stocks. And the color in this case is the stock that's being traded. Does that make sense? So in this instance, you can see there's a few, the kind of big purple ones, those are kind of regularly traded. There's a yellow line that's going through. There are very many stocks that are being traded on the market, and they're all different from one another. Am I going too fast? Oh, okay, a little bit, all right. So if we change this color to not represent the stock, but to represent the trader, the company that is making the trade on the stock market, we get a very different picture. It's almost exclusively in this picture. Goldman Sachs is doing almost all that trading. And we analyzed the day of trading in this way, and we made one of these for every 10 seconds of the day, and looked through them and paid attention to them. And we see things like this, where again, we have Goldman Sachs. But if you look through enough of these, you start to see patterns that are unusual and worth paying attention to. So here's the first example. You see in the middle there that kind of bunched up kind of band of very, very small trades. And they don't really follow any kind of pattern other than they have a very low cap and a very high margin. So they fit within this square, and they start all at once, and then they stop all at once. And they're all very, very small trades. If we look at them colored by trader, we start to see that all of those trades are being made by a single actor. So this is a robot in the stock market. This is a robot saying, I want to trade starting at 7:05 and 5 seconds. I want to stop at 7:05 and 10 seconds. And I want only to buy between €1 and €5, and only in very, very small amounts. That is not something that your stockbroker does when they're trying to make your pension a little bit better. This is something that a robot does. And this happens all the time. You can see here, we've got the color is the stock, and lots of different kinds of trades. And then there's this kind of funny blue kind of streak. It's almost as though this robot is kind of painting in the stock market, and it has its own flavor. So let's look at the first maybe 10 minutes of what a typical day on the stock market looks like. This is pre-ringing bell, the opening of the market. And so we've got a few robots kind of hanging out in the corner, relaxing. The purple lines across the top are the market just pinging the very bottom of the market and saying, is it working, is it working, is it working? And as we move forward, every time I'm moving forward, it's about 10 seconds. So kind of calm. And then a few minutes before the market starts, we see some robots doing a little dance, having some fun. About a minute before the market opens, we see this just complete barrage of robots making little gestures and making little, and they're all within these kind of narrow bands. And you can see there's a band at the top and a band at the bottom. That's one robot kind of tickling the top and the bottom of the market, saying, is it working, is it working? So that goes on for a while. Then it calms down. And then the 9 a.m. bell rings, and suddenly all the robots make their puts. All of this information is happening in about the space of 30 seconds. So every one of those is a monster trade they've been waiting all night to do this. You see some funny patterns in there, and this is about 30 seconds, and what I've been told is that the distance of the computer that does the trade from New York City is responsible for the distance of the trades. Everything is measured in milliseconds, and so if you're making an order from Europe, your trade takes longer, it registers later. So the robots are kind of competing with each other. So then the day kind of slowly starts to move forward, and eventually we start to see our friends, the green and blue and pink robots, doing their thing. So that's kind of cool. I think there's this landscape of activity in the stock market, and there's robots moving through it in ways that humans don't. It seems pretty clear that these are not humans. And if you look closely and if you use your eyes, you can start to understand a bit more about how the robots operate and what kind of structures they have, what kind of forms they have. I mean, I think it's worth thinking about this in the context of order and disorder, because what these pictures show is that there's very definitely an attempt on the part of the robots to exploit this kind of orderly nature of the market. They kind of go in and they try and find these cracks and surfaces that they can move on in order to make different moves than humans do. So if we want to look for new kinds of order, we have to start looking at what the machines are looking at. So this is the second project I'd like to talk to you about. It's maps for robots made by robots. We start with satellite imagery, and Digital Globe has a platform that lets us query at scale different kinds of satellite images and do things with them. But the problem is that once you get over the amazing fact that these are images taken from space, in and of themselves, they're kind of boring. And what's interesting about them is their potential and what you can do with them, and that's what we wanted to investigate. And so what can you do with these things? So these are 3 pictures of New York City. I think that's Yankee Stadium. And there's lots of other information you can combine with satellite imagery. We've been looking at things like building footprints, which you can get from OpenStreetMap. You can just find the outlines of all the buildings. And you can also get demographic information, information about the people that live in different towns and census areas. And so we're looking here at the wealth of the people that live in those areas. So the red is very wealthy, and the darker is very low income. And so you can see in the left-hand image, you see there's a kind of poor neighborhood surrounded by a very wealthy neighborhood. And that's a social housing project, which in the US is only for poor people because we haven't figured out how to have a decent society yet. And the two other images show middle to low income places with lots of buildings on them. So if you think about the world in this way, and it's this kind of layering of all these different kinds of facts that you can tell about the world, and it turns out that robots, when they do look at the world this way, they come up with some interesting conclusions. So we trained 2 neural networks, which is a fancy way of saying a set of algorithms and computers and resources that can analyze imagery. And so the first one, and so we basically made 2 robots and we made them fight. And that's what I'm going to show you. So the generator makes fake satellite imagery from census data. It takes these kind of green and red and images, and it tries to generate a satellite image from that. And then there's a second one called the discriminator, and that one distinguishes real satellite images from fake satellite images. It knows what real satellite images look like, and it can tell the discriminator, or the discriminator can say what they are. So the interplay is that the generator tries to fool the discriminator. The generator tries to make things that the discriminator will think are satellite imagery. And then the discriminator tells the generator, no, it doesn't look like a satellite image, change it. So now you have these 2 robots trying to trick each other, and you repeat this process. It doesn't really matter how many times, 100 times, 1,000 times, 1,000,000 times, because they're robots and they don't get tired. So eventually, sometimes quickly, sometimes slowly, the generator makes satellite imagery that is good enough to fool the discriminator. And that's the middle image that you see up there. On the left-hand side is what the discriminator uses. The right-hand side is what the left-hand side is what the generator uses. The right-hand side is what the discriminator says. And in the middle, they make this kind of image that is not real satellite imagery, but is kind of like satellite imagery. And the point is that it's good enough for the robots. And all of these pictures of New York, we can basically draw fake pictures of New York City. But they're fake in a very specific way that a robot thinks they're real. So we can draw our own satellite data now. And a robot will be able to tell us about the economic status of the people that live there. So what should we do? Well, the first thing we thought we'd do was to make movies of this fake but real enough data. So in the middle is the kind of machine vision version, this kind of, it's fake but real enough for a robot satellite data. And I wanted to show you those in a couple of experiments that we started doing here. So this is a pan along the East River of Manhattan. And it's the first time I'm seeing it on a screen this big. We have no roads yet, so this is all kind of in progress. The second one is a zoom in and out of Brooklyn. So on the right, you have the demographic data and the housing data, and it's all kind of lined up, and you're seeing a robot's machine vision of what that place looks like. So now things get weird and strange. So in this one, on the left-hand side, we have generated imagery, and on the right-hand side, we have real housing data. But the demographic data, the data about rich and poor, is fake. It's these bands of rich and poor just kind of laying there. And as the bands of rich and poor start to move through a neighborhood, they start to change the characteristics of the physical world. So remember that red is high income and the dark red is low income. So these are bands of low and high income kind of rolling through a neighborhood. It's like these waves of gentrification that just roll through a neighborhood and transform it and then leave destruction behind them. They go in and they make fancy coffee shops, and then behind them is just poverty. So it's like an animation of the built environment of capitalism happening in real time. So this is very strange to me and weird to me, and a little frightening to me in some ways, that we can make things that the satellites and the robots think are kind of good enough, but this is going to start happening more and more, and we're running out of time. So we need to start taking these things seriously. And whether or not this is how we see the world, this is what the robots see. When the robots are looking at satellite imagery, when the robots are looking at your credit card, they see the world in these different ways. And so it's important for us to get better at talking about this, because not just so that we can critique it, or not so that we can stop it, but so that we can engage with it and figure out what parts of it we want to encourage and what parts of it we want to use. Robots see things differently than people. They see order and disorder, structure and flow much differently than we do. Some of it's fascinating, some of this is worrying, but we should talk about it more. We should use our eyes to have these conversations as well as our brains. It's too important to leave it to the programmers. Thank you for having me.